Okay, the last four. Vertex is, okay, so now we've got the focus for the last two problems. Now we're at the directrix, so we're working from behind. So it's the same strategy. We can actually figure out that p-value relatively quickly. So we got a vertex of 0, 5. So just to kind of, what you might want to do is just consider doing this so that if the vertex is x, we can just put an x there, and then y minus 5, and then just look at what you've got as possibilities. And I see that there's a couple of possibilities, B and D, but it ruled out other things, so that's kind of nice. But we do need a value right here, so let's figure out what that guy's got to be. So if I'm at 0, 5, x is 0, positive 5, okay, up here, and the directrix is 6, okay? So that means it's above him, so this means that the flow of the parabola has to go downward, okay? And so we know he has to be negative. The p-value is going to be negative, okay? And also, that distance from here to here is 1. So we're saying that p equals negative 1, okay? Because we're pointing downward, and that distance from 5 to 6 is 1. So we're going to point that guy down. And so now we just have to multiply both sides by 4 so that we can see what the 4p has to equal. And that looks like between the two here, this guy and this guy, it's going to be that negative 4 in front of the y minus 5 parentheses. Same philosophy here. Go ahead and get 1, 0. He's going to be right there. The directrix is 1/2, so he is up above him, okay? Which means that this guy's also going to point, oh man, everything's pointing downward. This is ridiculous. So the focus is over here, but they're not asking for the focus. We don't need the focus. We know that the distance between this directrix and the vertex is going to be p equals 1/2, okay? So if I want to, and he's going to point down, so we might as well make that negative, okay? And so for p, we're going to go ahead and multiply both sides by 4. So if I did that, I end up with negative 2, okay? So I just multiplied both sides by 4. 4 times 1/2 is 2. Throw on the negative. All right, so here's our guy. Our value is going to be negative 2. So let's just make sure that we've got the right stuff here. If the vertex is 1, we're going to have x minus 1, and then y will be by himself. You don't have to put in the 0, but we are going to put that negative 2 in front. So we are looking for a negative 2y right here. Okay, C. All right, so next, I just got a message here. Okay, all right, Okay, so next, let's go ahead and grab, and a good, that was a good on my text. All right, so we got to get this into parabola formation. Where are we at, 3 minutes? Okay, we can do this. Let's keep the y minus 6 over here. And then we're going to move the x's over to the other side, so we get a 3x plus 12x there, okay? All right, now let's just think about this then. Let's go ahead and factor out we need this to be in parentheses. This guy's already in parentheses, although I think the negative 6 might change. We'll kind of see. Maybe not. Let's take out a 3, okay? X squared plus, you know what? Take out a 3. Yeah, no, we want to take out a 3. Okay, right there. Okay, and then y minus 6. So yes, that minus 6 is going to change. Okay, so we got these two x's here. We're going to have to complete the square like we always do, right? So if we do that, make sure that I didn't drop that 4. We're going to cut the 4 in half and then square it, so that ends up being a 4. But that means we're adding positive 12 to both sides because that 3 is in front. So it's the same gameplay, completing the square, just like you did with the other shapes. So let's make sure that we add that 12 over to the other side, okay? So adding those two, we're going to get a y plus 6, okay? And then this guy becomes 3 x plus 2 quantity squared, okay? So now we got the parentheses that we're looking for. But notice, though, that the 3 is on the wrong side. So let's just do this real quick. Wrap him in parentheses, okay? And we're going to divide both sides by 3, and it's not going to interfere with the parentheses in any way. So if I divided this guy by 3, okay, that's essentially saying that I've got 1/3, okay, and then this guy will just be x plus 2 squared. Okay, so it's kind of weird, but our p-value is connected to 1/3. So 4p, now I already know the vertex now. It's going to be -2, -6. Okay, those are my parentheses. But 4p has to equal 1/3. Okay, so if I divide both sides by 4, I'm going to get a p equals 1/12. Okay, so he's going to open up quite wide because the focus is going to be very close. Okay, so let's go to -2, -6 right here. He's positive. He's going to open upward, but I'm only going to go a 12, so he's barely going to be recognizable there. Like, he's going to be super close, all right? Now then, what we do then is we look at what 4p equals. It's 1/3. So this guy is actually, oh, he's going to be really, he's only going to go a third this way and a third that way. So this means that this guy's going to open up quite tight, actually, okay? Quite tight. And because they're going to be really, really close to each other, okay? Yeah, okay, right. So for some reason I was thinking the large p-value would open up this way, but of course not. It'd have to be real small. Okay, where are we at? 6 minutes? Okay, I'm going to do this one. Okay, let's go ahead and get the y's over to the one side. Okay, so let's get that -2y squared. No, you know what? Let's keep it positive. Okay, let's actually move the x over there. Okay, and then we're going to move the x and the 70 over there. Okay, so we'll make those guys negative. So I'm going to take a 2 out of here because I need to get those parentheses. So we're going to divide the 24 by 2. Okay, -x minus 70. There we go. Now we're going to go ahead and split this guy in half 6, and then we're going to add 36. Now 36 times 2 is actually positive 72, so that's what we added to both sides. So then 2, get those parentheses here, and we're going to get square root of this guy, square root of that guy. That positive sign sticks with here. That's just the formatting that we've been doing when we complete the square, that algorithm. All right, so then we get a -x plus 2. Okay. Now, this guy's in the wrong location, and I need parentheses over here. I don't want a -x. That's not how the transformational form works. Hey, what's up? Okay, can you just put your name on the board and just put what number you have? That's totally fine. Cool. All right, so let's go ahead and actually get this guy in parentheses. So what I'm going to do is I'm going to take the negative sign out, okay? And because I don't want the negative sign on the x. So this is the best way to do that. So I took him out, and then whatever comes over here will just be negative, okay? And then we'll graph them. Because that 2 cannot be on the parentheses with the quantity squared, right? So we're going to move that 2 over here, and he will become 1/2. And he'll be negative because we need to make the x positive. Okay. All right, so now we're ready to graph this guy. We see that the vertex is 2, -6, 2, -6. This guy's going to open... why do I feel like... Oh, whoa, okay, whoa. All right, wow. All right, the y is squared. He is going to open to the left. Okay, so he's going to open up this way. I'm so used to everything being up and down. He's going to open up to the left because the y is squared, finally, and we've got a negative p-value. So he's going this way, and with that 4p equaling 1/2, we're going to divide. That's going to be 1/8. So he's going to be pretty close here. Then we're going to double that this way. All right, so he's going to be something like this. All right. All right, and I'm going to double check that and make sure it's correct. All right. But I did kind of go fast here because I'm at the 10-minute mark almost. All right. See ya.